Hi everyone. This video is on the binomial theorem. We have this notation that we're going to work on. It looks like a fraction, except that there's not a bar in the middle, and it's surrounded by parentheses. So this notation, it's read as n choose r. It's used often in probability. We're not really going to work on probability, but if we were, a way we would say this is it's the number of combinations of n things taken r at a time. For example, if we had 4 people, how many different groups of 2 could we choose? And we could get that by using our calculator. The button that we use on the calculator is an NC, looks like NCR on the calculator. So 4 choose 2, the result would be 6. I know there's different kinds of calculators. I'm going to try to go through a little bit of it, but you might have to go to YouTube to figure out how to do this on your calculator. Or hopefully you could ask your teacher or a tutor. So here we have some directions on how to type in 10 choose 7 on the Casio. Type in the 10, then press the shift key, then the division key. If you notice on the division key, right above it in little yellow letters is the letters NCR. That stands for combinations. To the left of that is the times button, and in little yellow letters is NPR. That stands for permutations. So if we were taking a probability class, these buttons are extremely important. One stands for combinations, the other stands for permutations. Okay, we won't get off track. So 10, shift, the division, and then 7, and on your calculator it should say 10 NCR7. Then press the equals and it'll give you 120. On the TI-30X2S, type in the 10, then you have a PRB button on your calculator. PRB stands for probability. And you'll see some choices, NCR, NPR, and an exclamation point, which is called a factorial. And then use the arrows to underline, so you can move the underline to either one of those choices. Once it's underneath the NCR, then you could press enter. Then the 7 and press enter again, and you should get 120 one more time. Maybe you have a graphing calculator. So again, you'll type in the 10. This is a Texas Instruments graphing calculator. A Casio graphing calculator might be a little bit different. Okay, so a Texas Instrument graphing calculator, type in the 10. Then you have a math button on your calculator. It says math. So press the math button and then use the arrow to go up or down till you get to probability. Sorry, it's left to right. Use the arrow to highlight the PRB button, and then you'll get a new list of options, and then with the arrows you'll scroll down till you get to the NCR, then press your enter button. Type in the 7 and then enter, and you should still get 120. Okay, if this is not one of your calculators, you might have to go to YouTube or get some help with your calculator. Many of them are quite different, but you're looking for the NCR button. Okay, this is the binomial theorem. For algebraic expressions, x, y, and any natural number n, x plus y to the n gives you this pattern on the right. We would say in parentheses n choose 0, and then n choose 1, and then n choose 2, all the way till you get to n choose n. we're going to use our calculator to get those numbers. N is the exponent on the parentheses. So you might be asking, why do we need to do this formula? Well, if we were trying to calculate x plus y to the second power, that's easy. Or x plus y to the third, we could do that also. But what if it's x plus y to the 8th power? We have to write x plus y 8 times, and then that's a lot of multiplying and distributing, and most likely we would make a mistake. I would definitely. So this formula will give us the answer without having to go through that whole process. Okay, now looking at this formula, the first term is x. Notice that its exponent is n on the right hand side. So it's x to the n. Then what it does is it decreases by 1. So in the second term, it's x to the n minus 1. And in the third term, it's x to the n minus 2. And in the last term, it's 0. So for example, if n was 7, it would go x to the 7, and then x to the 6, and then x to the 5th, and then x to the 4th, until you got to x to the 0. Now notice the y, the second term. Its first term is y to the 0. The second term is y to the 1. The third term is y to the 2. It keeps going until you get to y to the n, whatever n is. Okay, so hopefully the pattern makes sense. Here's some notes if you want to write that down. The powers of x are decreasing while the powers of y are increasing. For each term, the sum of the exponents on the x and y expressions is n. And the top number of the binomial coefficient always equals n. So the binomial coefficient is the n choose 0, n choose 1, n choose 2. For each term, the exponent on the y expression and the bottom number in the binomial coefficient are always 1 less than the number of the term. So for the first term on the coefficient, it's 0, and the y has an exponent of 0. On the second term, the exponent of y is 1. On the third term, the exponent of y is 2. On the fourth term, the exponent of y would be 3, etc. Okay, here's our first example. Use the binomial theorem to multiply or expand x plus y to the 6th power. Right, let's write down our formula. And note that n is equal to 6. So n is the exponent on the outside of the parentheses. Okay, so our n is 6. So everywhere we see an n, we're going to replace it with 6. Let's see if we could write this down properly. So it's 6 choose 0. That's how we'll say it, 6 choose 0. And then the x, or the first term, starts out at 6. And then it's going to decrease each time until it gets to 0. So it's x to the 0, x to the 5, x to the 4th, x to the 3, x squared, x to the 1, x to the 0. And then the y, the second term, is going to start at 0, and then it's going to increase until it gets to 6. Okay, you might want to pause, make sure you have it written down correctly. And then in between, there's a plus sign in between each term. Okay, hopefully the pattern's making sense. Now we need to figure out the 6 choose 0, that binomial coefficient. So on your calculator, type in 6 NCR 0, and then get that answer. And then it's easier to do all those first. So then just hit backspace on your calculator and then replace a 0 with a 1 to get the next result. And then backspace and replace it with a 2, etc. So these are the numbers that you should get for each one of them. 1, 6, 15, 20, 15, 6, and 1. If you've taken an Algebra 2 class before, you may recognize these numbers as Pascal's triangle, one of the rows of Pascal's triangle. Okay, so if you heard of Pascal, French, 1600s, so this math is from the 1600s, but it was already done before. You know, it was published in France in the 1600s, but in the East, it was done by Yang Hui in the 1200s, or Zhang Qian in the thousands. Even in Persia, it was also done in the 900s by Al-Khamarji in the 900s, or Omar Khayyam in the thousands. In India, it was also done by Bhattapala. So it was already done many times over in other countries. But here in the United States, we would use the name Pascal's triangle because he was French. In China or India or places in the East, they're not going to use a French name to describe what was already done. Okay, so that's where those numbers come from. Now we need to simplify. So 1 times x to the 6th, y to the 0, plus 6 times x to the 5th, y to the 1st, etc. And then simplify it. Get rid of the parentheses, and anything with a 0 power is always 1. So for the first term, we could simply write x to the 6th. The second term is x to the 5th, y. The third term is 15 x to the 4th, y squared. All the way till you get to the last term, which is just y to the 6th. I know, it's kind of a long problem. You might even want to put your paper horizontally when you do these. I suppose I could have said that earlier. Sorry. Okay, so it is a very long horizontally problem. Okay, here's our next example. It's not just x plus y, this one is x plus y to the 5th. So in this case, we're going to substitute the y with a 7 in the binomial expansion. So we start out at 5 because n is 5, right? Or n is 5. So we start out at 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, all the way until we get to 5 choose 5. And in the first term, our x starts at x to the 5th. And then it decreases until we get to x to the 0. And in the second term, which is a 7 this time, has an exponent of 0 and then increases until we get to 5. Okay, it's important that we see the pattern. If we don't see the pattern, then it looks like a big old mess. All right, let's get the coefficients. So type those into your calculator, and you should get these numbers: 1, 5, 10, 10, 5, and 1. Now a little bit of simplifying. The first term, we could just remove the parentheses, the x for the x to the 5th, x to the 4th. But the next one, though, 7, well, 7 to the 0 is 1, 7 to the 1 is 7, and then 7 squared is 49, etc. So we're going to work out each of those and then multiply the coefficient in front times the result of the 7. So it's a lot of rules with exponents that we have to work on here. So So like for the third term, for example, 5 choose 2 is 10, and then 7 squared is 49, so we have 10 times 49. And in the third term, 5 choose 3 is also 10, and 7 to the third is 343, etc. And then simplifying that, here's our final answer. Okay, let's go on to the next example. It's getting a little worse. Sorry. 5a squared plus 4b cubed, again to the fifth power. So our n is 5. This time, our first term is 5a squared. That's our x. And our y is 4b cubed, our second term. So we're going to use our formula. And instead of x, you're going to put a 5a squared in place of the x. You might want to put it in parentheses. And our y is 4b cubed. Okay, here it is. 5 choose 0 times 5a squared to the fifth power times 4b cubed to the power of 0. So I'm not going to read the whole thing, but if you look at the pattern, the binomial coefficient is 5 choose 0, 5 choose 1, 5 choose 2, all the way until we get to 5 choose 5. And then the first term, 5a squared, versus to the fifth power, then the fourth power, then the third power, all the way till you get to the 0 power. Then the second term is 4b cubed. It starts out at the 0 power, and then it increases until we get to the fifth power. Now we got to work all that out. So 5 choose 0 is 1, so get those numbers first. And now when you rewrite it, you're going to have to figure out what 5 to the fifth power is on your calculator. And then 5 to the fourth power, etc. So then this is what you should have. You might want to pause and then go through each one. Now multiplying the numbers of each term and then writing the variables after that will give you this answer. So like in the first term, we have 2 1s and then a 3,125. So that just leaves us with 3,125. In the second term, you have to multiply the 5 times the 625 times the 4, and that gives you the 12,500. And then we just carry the a to the 8th and b to the 3rd right after that. And again, how do we get the a to the 8th? If you look at the second term above, it's an a squared inside the parentheses and then the 4 on the outside. So the rules of exponents are to multiply the exponents when 1 is outside. So 2 times 4 gives you 8. And then for the b in the second term, it's 3 times 1, which is 3. On the third term, it's 2 times 3 for the a, which is 6, and 3 times 2, which is also 6 for the b, etc. Okay, this example is a little different because it has that minus sign in the middle. The formula had a plus sign in the middle. So therefore, when we use 3 for our second term, replacing it with the y, we're going to have to use negative 3. So not 3, but negative 3. Okay, so 2p to the third, that's going to be replaced for the x. and negative 3 will replace the y. Okay, so here's our formula. 6 choose 0, 6 choose 1, 6 choose 2, all the way till we get to 6 choose 6. And then 2p to the third to the 6th power, to the 5th power, to the 4th power, all the way till we get to the 0 power. And then a negative 3 starting at 0 and then increasing by 1, so negative 3 to the 1, negative 3 to the 2, all the way till we get to negative 3 to the 6. Okay, a lot of calculating to do. So like in the first term, 6 choose 0 is going to give us 1. I would probably do all those numbers first. Or we just use those numbers on a previous example, just copy them over. And then when we do 2p to the third to the 6th power, you have to do 2 to the 6th power, get that answer. And then p to the third to the 6th, we have to multiply the exponent, so that'll be p to the 18. And then negative 3 to the 0 will be 1. And then move on to the second term. Alright, so I wrote the numbers above, 1, 6, 15, 20, 15, 6, and 1. And now there it is. You might want to pause, make sure all your values that you calculate match, and then simplify it even further, and that should be your final answer. Okay, one more example. Alright, last example. This one is to the 15th power. Luckily, we only want to find the first 3 terms, so it's not too bad. Alright, so this time we're going to substitute the x squared for x and the 3y for y in the expansion. So we start out at 15 choose 0, and then 15 choose 1, and then 15 choose 2. That's enough for 3 terms. And then the x squared, we start out with an exponent of 15, and then we decrease it by 1 for the first 3 terms. And then the 3y, put in parentheses, start out at 0, and then the second term is a 1, and the third term is a 2. Now we just need to simplify. So 1, 15, and 105. This is probably the only benefit of using the calculator and not the triangle right now. Unless we were in a probability class and we had to find random NCRs or NPRs, it's good to know how to use the calculator. So if you take stats next semester or later, that NPR and NCR will be valuable in the probability section. Actually, even in some algebra classes, doing a little bit of combinations and permutations may be required. Alright, I'm getting off track. So now simplify each one. So in the first term, 15 choose 0 is the 1. X squared to the 15th, that's x to the 30th. And 3y to the 0 is 1. Anything to the power 0 is 1. In the second term, 15 choose 1 is 15. X squared to the 14th is x to the 28th power. And then 3y to the 1 is just 3y. In the third term, 15 choose 2 is 105. X squared to the 13th is x to the 26th. And 3y squared will give you 9y squared. Simplifying that even further, we get our answer. So that's the last example in this lesson. Have a good one.